Hello, everyone. Thank you so much for joining us today. Today, we are having the session on building a resilient, highly available Postgres cluster with Patroni, pgBackRest, and LUKS. I have with me Semab Tariq as the speaker of this session. And Semab is going to walk you through all the process and steps that are required to create a production-ready cluster. So before I hand over the mic to Semab, let me go over a few housekeeping items. This webinar is being recorded and we will share the recording with you afterwards. If you have any questions, please feel free to share either the Q&A box or the webinar chat feature. And that's it from my end. Over to you, Sama.
Yeah, thank you, Annie. Welcome everyone. I'm really excited to, of course, talk about high availability again, as this is one of my favorite topics as well. So today, instead of just theory, I want to walk you through to a real world success story where we helped our customer to set up a customized, high available Postgres cluster solution using all sort of open source tools that are available. This was a highly customized solution, which was of course designed specifically to meet the unique requirements from our customer and their environment, of course. Before we actually get started, first thing first, and that is introduction. So yeah, of course, my name is Semab Tariq, and I work as a Postgres consultant at Stormatics. My initial journey with Postgres started back in 2018. This is when I joined second quadrant as automation engineer, and I used to work on Postgres community installers and CUDA installers at second quadrant. After then, I joined Enterprise DB in 2020. This is where I was again working with the Postgres community installers, releasing them and building and releasing all sort of builds. And currently, of course, working as Postgres consultant at Stormatics. And at Stormatics, we are keen to provide professional services for Postgres that include high availability, performance monitoring, backups, and recovery solutions as well. So yeah, this is sort of agenda about what we are going to cover in today's session. So first of all, we are going to understand what high availability is and what are the main types of highly available clusters. And then we are going to see what is the best highly available cluster for your businesses or mission critical applications. And then we are going to understand or see how we actually help our customers to implement a real world highly available solution with the help of Patroni, pgBackRest for backups and recovery, and LUKS for encryption for data, encryption of data at rest. And then finally, there will be a question and answer session as well. So first thing first, of course, let's first start with the basics of what is high availability or HA, you can say. In context of Postgres, HA actually means that keeping the database accessible at all the times, even during failures or planned maintenance activities. Well, it shouldn't matter if you are applying patches on your application side or database side, or you are restarting your database service, or you have faced or you are actually dealing with some sort of unexpected hardware issues and the service. Your application or database should be accessible to all the customers in all these sort of scenarios. And once you build this sort of application that is accessible throughout the year 24/7, then you can say this is a highly available cluster or solution for your needs. The next question would be, how do we actually measure high availability for our systems? Well, most common way to actually measure the high availability for our system is actually we measure it using uptime percentage of our system. Like if like we can say our system is 99.9% of highly available, that actually means that we are saying that across throughout the year, our system will be 99.9% online throughout the years, for of course. So in numbers, if I talk about if I am saying 99.9% of high availability, it actually refers to it actually means that our system can be down or we can face some sort of downtime of 8 plus hours throughout the years. And this is throughout the years, not per month. And if we say that our system is 99.99% of highly available throughout the year, that means we can expect 52 minutes of downtime per year. And similarly, if we say we have our system is 99.999% of highly available, in short, we call it 5 nines of high availability. That means that we can expect our system to have a downtime of at least around 5 minutes per year, which is again on a very low side if we have a 5 nines of high availability. Now, how do we actually track and improve the high availability for our system? We actually use two type of metrics, like we have mean time to failure and we have mean time to recovery. So let's try to understand these metrics in details. So mean time to failure actually tells you how long a system was operational before a downtime was hit, or something actually goes wrong with that system. So whereas mean time to recovery actually tells you how fast a system is recoverable from an issue. So usually we expect a higher, of course, mean time to failure and low mean time to recovery. And let's try to understand these two concepts from from example below. So let's say you have a system and that system was up for 180 days before hitting a downtime. So your mean time to failure would be